Hi folks, it is awesome to be here. We are at EMO in Milan 2021. It feels great to be traveling again. This is the biggest machine tool show in the world. So we get to spend the next 2 days looking all over. There are 7 buildings filled with everything CNC related, manufacturing related. It'll be really interesting to see what are people pushing, what is the next thing, what are the coolest machines. I'm really excited to walk around. I'm really excited to see it. I brought my wife for the first time ever. So let's walk around, let's see what we find. If you haven't heard about EMO before, it happens on a 2-year cycle, and it goes Germany, Italy, and then it repeats that. I had the chance to see the one in Hanover a few years ago, which was amazing. So I'll be curious to see how is the one here in Milan different. Let's go see what we find. So we actually just got a Genos M660. The next machine up was this, the MB80. It looks totally different than the Genos M660, but it's actually not as different as you might think. It's still a double column machine that has a traveling table and a fixed head, but it's more of what you'd see as a traditional bridge mill design, if you will. Really nice operator table access here when the door opens, overhead loading, and it's just a step bigger in terms of footprint and travel.
A small tool for a big block of steel.
We're also really excited for the open architecture of OSP. They have an API that allows you to integrate with the machine. We think we can even potentially tie in Lex, which is our homegrown ERP system, with the machine control. So in theory, you could even have it say, like, when a job comes up, Lex could tell you information about the work order, the spec sheet, the PDF. Like, that's really cool. Ed and I went down to Charlotte when we were looking at our Genos to spend some time on the machine, and they had a secret demo of what is now clearly out, which is their Armroid and other Roid level internal sort of built-in automation system. So this one looks like it's a Multis that's built for the Armroid. So it's a pretty cool idea of a relatively simple turnkey automation. I do like that it's from the OEM, so there's going to be one provider for the whole solution. And oh, here we go. Oh, look at that. The robot's inside the machine. Oh, that's slick. Relatively large parts to be robotically loaded, and robotically loaded through a 4th axis. And again, the like crazy, not secret, but secret thing is Okuma makes grinding. We were able to show this off when we did the Metal Quest tour. The GP26W, it looks like it's dressing the wheel back there in the corner. I mean, the diameter is huge. Oh, look at that probing in. It looks like it's going to probe the part. We saw that again at Metal Quest. They had the, I think, a MARPOS system, so they were able to do in-process inspection. Totally makes sense on an application like grinding. And I don't know if we're going to see any sparks fly here, but still really cool. I always love the fact that something as simple as between dead centers can be just the end of the road accuracy, plenty good, and then a relatively simple drive dog system. A newer integration that looks like, but still that MARPOS system. I will never get tired of seeing big tool changers. I think the illumination is probably a little bit of a showmanship on the trade show, but still really cool. My wife just smiled and said, it's really fun seeing you with these, and it occurred to me, she's never been to one of these. She's never even really seen much of what I do here, so it's kind of fun. The EMO hospitality we saw in Germany, and it looks like it'll be true here in Milan, is incredible. Like, every booth has unbelievable food and coffee, and it really is crazy. I believe the -L means this can do turning as well. It's also just a giant 5-axis. aside from wanting to see the awesomeness of a trade show, one of the real reasons I'm here is we had spent some time looking into a Swiss turning machine as a way to make some of our Saunders Machine Works parts. I think we have a lead now on a used Wilhelm. In fact, by the time this video comes out, hopefully we'll have more news on that. But one of the things that made it difficult when we started to look at it is how do you configure, like that part back there is called the horn. You have different options when you purchase the machine. That has a, I don't know the correct term, a driven or controllable horn, if you will, which is really cool as well. If you know the few parts you want to make, it's not particularly difficult, but to buy one and have it spread across a different group of parts is not the easiest thing to do. And here is Tiny Swiss, the R04. We saw one of these, I believe, when we toured Nicholas Hacko Watchmaker. I believe this is what Danny Rudolph runs as well. R04 means it takes 4mm bar, or enlarges 4mm bar, which from memory and Freedom units is about 3/16 of an inch. I mean, look at the tiny tool holders. It reminds me of almost my hobby days back when I had the import lathe with 1/4 inch or 3/8 tooling. Tiny. Robot, round bar. That's so cool. Pinch milling, that's awesome. You got a driven holder on the bottom turret, proper milling spindle. I would have thought that the milling spindle would have finished first because it certainly has a higher RPM spindle. Traditional Integrex with the V-axis head, but then look, it's got a turret. It's mounted 90 degrees to what you'd expect. That's cool. Oh, then you can switch over to the sub spindle. Picking a battery cell, that's cool. Oh, interesting how it suctions them through one at a time to get the right alignment. Looks like they're probably tying into the electric vehicle market there, or even e-bike. I think it's just showing off. Having a little dance. We know you're fast. There you go, look at that flip speed. Isn't that nuts? Oh. We just saw this size machine at the 3rd gen machine tour. It's a typical phone booth machine. Awesome for high density, or having a pair of them with a robot and feeding 2 machines. Look at that. Not a CNC machine, but think about you have a bunch of 80-20 work to do. Throw a drill in a robot. I'm guessing it could tool change as well. And injection molding. Fanuc really does everything. They've got EDMs. They've got these diamond glass cutting machines for lenses. Look at that. Oh, that's awesome. Putting them each in an individual bin to mark them. Love it. It can snap them off. That's really cool. Picks the tray up, slides it out, and dumps them. Oh, that is awesome. Oh, that is awesome. Grimsbow's gonna love this. It's like that idea of, you know, you have enough batch flow and then at some point you can dump the batch. I love how it breaks it off though. Medical work. Oh, making a syringe. That's cool. Oh, look at the tiny pulley. I love finding big grinding companies that, you know, we've never heard of in the States. Linear motor. I mean, look at the size of that wheel and table and magnetic chuck. Ooh, it looks like a insert reamer. That's cool. Holy cow. it's a roller chain, so we can still slide it underneath it, but feed forward as needed. The other SMW, and then look at the size of these chucks. Oh, interesting, hybrid. It looks like it's both mechanically clamping and you can see the poles for the magnetic side of it. Oh, and then is this a rotational chuck? So I think what this can do is the chuck rotates and then your part can re-index inside the chuck. So 3 or 4 position work holding without actually changing your clamping setup. Absolutely love these machines. It's a 6 spindle lathe. It's running 6 times faster. The coolest part is how they handle the work transition. Back turning, it's so cool. Our friends over at MetalQuest got one just after we had the chance to film a tour there. I really want to either get back there or figure out a way to do a video showing the more in-depth look at how they're making parts on it. It's just so cool. But if you want to make 1,000,000 parts of something, this is your machine. There you go, you can see the back turning, working, back cutting. Oh, so cool. And there, it spits it right out when it's done. Yes! Nice, neat.
Can't take it.
So the machine business there, and then look at the bar feeder. It just keeps going. Index G320. Goes to its home, gets a new tool. That's a fast tool change, actually. Gosh, look at that. Some tight clearances on some of that turning. And part outloader. So walking around, I had the chance to meet.
Yeah, Savo, Stjepanovic.
And what you guys make?
Yeah, we made accessories for the sport shooting and reloading also.
And you started in your garage?
Yeah, we started in the garage. I bought some Haas machines on the auction, the first, and now we have like 5 new machines. So.
And you said 10 employees?
Yeah, about 10 employees. Yeah. The company was opened about 2017. That was like 4 years ago.
4 years ago, yeah.
4 years ago.
That's awesome.
Yeah.
Cool. And you use Fusion?
Of course. We
Yes.
just used Fusion. It was a time that, 2017 was just starting.
Yeah.
Thing.
Sure.
And I think I was the only camp programmer that uses a Mac. So I'm a Mac
The
user.
only choice.
Yeah,
That's funny.
the only choice. Yeah.
But your background is not machining.
No, I'm a software developer. So we make apps for the iPhones, for the Android.
Yeah.
I never been in the workshop. I even think I saw my first machine. It was my machine.
Serious?
Yeah. I just knew I have to make parts.
Yeah. And you figured it out.
Yeah.
Yeah, that's awesome. That's really cool. And what are you here at EMO for?
Yeah, just now we are getting bigger. Now we must go to see how stuff works. Maybe to look some kind of 3D printer or that's technology that interests us.
Cool. Additive.
Yeah.
Awesome. Cool. Hey, good to meet you.
Hey.
Heard really good things about these machines. Don't see them very often in the States though. Pretty good density automation for such a small footprint. Look at the tool changer. That is beautiful. I love the little locating pods that drop the pallet in just the right spot. Look at the tiny watch parts here. I don't even think these are really going to come through. Bigger parts. So the big difference, if you just saw the Citizen, is these guys feed the bar in from the left. But similar thing, you've got all your static tools, driven tools, the horn. Cool. If you follow the business of machining, you've probably heard us talk about the Compact 80. This is what Grimsmo has on his KERN. It is such an awesome solution. Here it's feeding a CMM, but it can feed 2 different machines, I believe one from each side. You can have different sized pallets. Really cool. Oh, and it can change out the gripper down there. Look at that. Dude, that looks like it's actually doing workpiece loading onto a automatic vise. I like it. Again, another brand, don't know it, but look at it. It's beautiful and it's huge. It's incredible that they bring these machines to trade shows, set them up, and make parts. So the whole trick with the trade show is to catch people's attention. This is pretty eye-catching. Holy cow. I gotta think that's the fastest. Yeah, look at that, 15 meters a second. I must admit, I don't really know what's going on, other than they want core. And they want a revolution.
Now, the time has come. It's time for a revolution. A digital revolution. A customer-oriented revolution. United Grinding's customer-oriented revolution. CORE. Let's begin.
Okay, so we figured out what all of the dance party was about at Walter Grinding. It is, you could say, just a new control, if you will, but it actually, I give them some credit. This is pretty legitimate. So on their machines, you can still have a Fanuc drive system, a Heidenhain, Siemens, whomever, but they have a built-in camera. So if you have a support issue, you can securely connect to a VPN through the Walters network to get directly in touch, again, on a secure connection with somebody who can see you and walk you through it. Or they have their own app that, again, they emphasize security here, where you can use your phone to walk around the machine and live stream information that you need to, or support issues to get direct and immediate help. So that's pretty cool. You can configure this, you can use apps, you can integrate it with ERP systems, or you will be able to, which again is great. The other thing I thought was pretty cool is it allows you to tie in other information. So if you have a centralized coolant system and you need to be monitoring the temperature of that or the bricks or something, you can do that as a sort of a third-party tie-in to this system here. So pretty interesting. They talked a lot about how they want to be able to take that next leap forward for automation, for machine tool technology, but also employees. But then also solving the problem of, to date, machines like this were sold and every single one looks different. The control looks different, the interface looks different, the menus look different, the capabilities are different. This allows them to start standardizing that. So, pretty cool. Look at that. You can switch to grinding wheels, or this actually can mill. Very cool.
Now you have next step, and you need another profile. That's why he changed the complete hair, the new and all.
I think I found the world's largest boring bar, and then look at this. I mean, just massive. With the articulating head and the separate operator cab. Just incredible. To think that you have not only rigidity, but stiffness and power, horsepower to take base mill cuts with that extended all the way out is just amazing. I mean, this is really incredible. You can have a second machine that shares the same robot, kind of standing where I am right now. You can change from pallet loading to workpiece loading. You can change grippers. You can even use this robot to change like sister tools, or to put in super big tools or long tools that wouldn't fit in the tool changer. You could use it to move a tool from machine A to machine B if it needed to borrow a tool. I mean, just incredible. I feel like I want to see a wash down station where it takes the vise over to like a little car wash and cleans it off. Drops the block. That allows it to be accurately picked the second time. Vise opens. And then and the door closes. It's amazing watching those robots articulate so gracefully. Oh, it's going to take the vise off. Awesome.
This part.
Okay.
So it's an injection mold for a like FFP2 filter mask. We did together with Heidenhain.
Yeah.
And it's actually roughed with the Heidenhain OCM function.
Okay,
So
what
the
is that?
ramping, the internal is calculated from a 3D model inside the control.
There's no cam.
There's no cam for it. Exactly.
Really?
And then we are actually hyperstatically jig grinding the boards
Yeah.
and 5-axis simultaneous grinding the radius there, just to get like high surface finish on it.
And is that the jig grinding nature in the tolerancing? Is that because you want to show off the current at a show, or is that something that would really be
That is
used?
actually, I mean, the boards, that is something you would actually always jig grind.
Okay.
Because the precision is super high, you
Yes.
have very, very low tool cost, and the surface finish is better than anything you could ever mill on that
Sure,
one
sure.
in the same amount of time.
And when you say jig grinding, you mean an actual abrasive grinding tool?
Yes, there is a grinding bit, and then because the machine has hyperstatic guideways,
Yes.
you can let the Z-axis oscillate.
Yes.
And it's actually machine controlled as well, so it's not a CAM toolpath, but again, you are selecting the contours on the model, on the control,
Yeah.
and then the PLC, so the underlying operating system of the machine, it does the oscillation of the Z-axis. And that is much quicker than when you would do it from CAM, because you have like no cycle time for the oscillation.
Incredible. So Marva's going to explain this, but what's incredible is this is a part made without cam.
Exactly. So what you're doing is you're selecting the actual 3D file inside a different program in the software. You're selecting the contour, and then you basically have a cycle, just like a boring cycle, where you are inputting which depth and height you have to take, and then Heidenhain actually has a calculator for the speeds and feeds built into the control with like every material imaginable.
Yeah.
You have two sliders where you can input the mechanical load of the tool and the thermal load. So if you have, for example, an uncoated tool, you can reduce like the thermal load, and then the cutting data comes out, and that actually fits like for every Heidenhain machine. So we didn't enter anything.
This isn't a KERN specific.
This isn't a KERN specific thing. It's just like a Heidenhain function.
Incredible.
We input, and if you have, I mean, this is a contour where no one actually would program on the control. But here it's so easy and so quick.
And
So
it's
really
adaptive.
cool.
It's a constant engagement toolpath.
Exactly. And you have no calculation time as well.
If you just update the solid model, you still have to select Is it doing a model-aware internal pocket only?
No, you have to select it again,
Okay.
the contour.
Yes.
But then it's just like instant generation. So the machine generates the toolpath quick enough that when it starts milling, it's already done.
So for things in traditional CAM, when you have a spline and it has to tessellate that and then convert the tessellation moves back to arcs and lines, and then that gets fed into a motion control, this takes a lot of that out of the equation?
Exactly. So for example, interpolation errors, when your cam tolerance is like too large, this doesn't exist here.
Yeah.
And there's also a rest material cycle and a finishing cycle.
Air blast clean. It's like the best 5-axis feature nobody talks about. Just cleaning the part out. Jig grinding. Incredible.
This is just aired, so it's not touching the part.
So tools rotating and stroking up and down. And when you do like when I think about a more jig grinder on the cylinder, you'd have an oscillating head.
Exactly.
This, you'd interpolate that?
The turn is so precise that we don't need the just like the machine precision lends itself.
But it's a hydrostatic.
It's a hydrostatic machine, exactly, so you have nowhere. This movement does not wear out the axis at all because you don't have moving parts. You have linear motors and hydrostatics. And it's actually a KERN design, and they have a gap height, so the film thickness is about a tenth of what is usually used in the industry.
Interesting.
And every property, like dampening, stiffness, especially stiffness, increases by a cubic measure with reducing the film thickness. So usually when you have a hydrostatic machine, it's kind of like wobbly, which is why you see it a lot on like ultra precision machines. Even though it has the same spindle as the Vario, a non-hydrostatic machine, you can take a much heavier cut and the machine is much more silent, less vibration. The only downside to micro thin film is you have to build the machine really precise.
Yes.
Because we are talking single-digit micrometer film thickness, so your axis needs to be like super smooth, super even.
Is the hydrostatic difference from even the pyramid?
Yes.
Okay. Wow.
The pyramid is like an old gen, so that has like 50 to 100 micrometer film thickness, and this one is in the range of 5 to 10. It's really cool.
It's the end of the road, right?
Yeah.
So this is really cool. We just walked into the KERN booth, and I wanted to say thank you to the CEO, Simo, because he actually personally helped make a Johnny 5 part for us. And when I said that, he said, "Oh, it's here." They made another duplicate Johnny 5 part. This is the part that holds Johnny 5's tool change, and it holds his pocket tool and other little parts, screwdrivers, and so forth.
So this is a piece of tungsten carbide.
Yes, tungsten.
And this is silicon carbide, which is about 3 to 4 times harder than tungsten carbide. Silicon carbide is what you have on your sanding paper, actually. And this is just like a demo piece we did.
Yes.
Every feature is milled in under 1 hour.
So why is that textured floor and some of it is smooth?
So this one is actually crowned, the surface.
Okay.
And this one is face milled. And you can see directly the difference in like our technology, because this one is highly reflective.
Yes.
You get a gloss finish to it. And this one is homogeneous, but also made.
I thought it would be heavy.
No.
Tungsten carbide is heavy.
This is actually not very heavy, and for engineering applications, it actually has like crazy good properties. So the heat conductivity is about as good as on aluminum.
Wow.
Which is crazy for engineering applications.
So rumor has it, when you need to make something like, you know, Apple-related accessories in the quantities of millions, look at this independent transferring. So kind of like what we saw in the index machine, where it's taking parts and rotating them around. Super interesting shape. Look at that, the door opens right there. Really good footprint. That's awesome. God, that's really compact for what it is. Still one of the nicest compact kind of entry 5-axis automation machines out there. The MX330. Actually, good example there. How much you can fit. 3 parts on a tombstone like that. More on a little guy there in the back. That's really cool. The new MAM. So if you've seen the MAM before, and we've certainly filmed them, they basically rotated at 90 degrees. So I'm not going to complain about that. You clearly have better operator access to the parts. So you probably have seen shrink fit tool holders, but check this out. It's an integral shrink fit ER. So anywhere you want to use an ER, but in particular something like a live tool lathe, or you were saying they make the tail end of this in an HSK style taper as well.
Yes, like small HSK tapers, yeah.
Yeah, so he just showed how we can automatically adjust based on scanning the QR code to the correct collar setting so it doesn't overheat this. You change the tool out, you've got an adjustable gauge length stop, and then it comes down and we can use the cooling feature. But I can't help but also notice, look at the extensions. This is incredible. Obviously more trade show than practical, but if you really need that gauge length, holy cow. And then look at that. Is that HK 100? I mean, that is just...
So we've got a Carbide extension.
Oh, that's an extension. I didn't even catch that.
And
Sure.
This is the thread-on style we call dual lock. It's a modular system.
Interesting. But it remains carbide, so you're grinding the carbide threads in
Yep,
there.
grinding the carbide.
Good grief.
And this one is for die mold or 5-axis. We've actually pressed the carbide rod in
Okay.
the center of the chuck,
Yep.
so that if you are out there, you dampen the vibration.
Just
And
stiffness.
this is the modular system as well, the dual lock.
Yeah. And is there a torque spec, or is it just a hand tool to put the ends on?
Torque spec, we have a torque wrench.
Okay.
You can use a hand tool, but we highly recommend the
Yeah,
torque wrench.
sure. Look at the little ER11s. That's cute. All the way up to 32.
Yep.
This is great. Strength automation cube. Put your next tool in the pocket. This carousel moves around. It's going to automatically remove the old tool, put the new tool in, cool it down. That is sweet. Love it. What is it? The cutting operation?
Ground gear skiving.
Yes, sure.
Yes.
Very nice. Oh, the skiving. That's
Yes,
amazing.
yes.
So cool. It's a carbide replaceable insert.
Yes. This one we don't smooth with the brush. We make it with a special milling tool.
It's cutting a gear from the side effectively as a
Yes,
deburr.
yes.
That's incredible.
Now we do form grooving.
A form tool, yeah. Look at that.
That's parting up about your wire axis.
It is Y-axis parting.
Yes, yes.
Seeing a dual spindle lathe come in and grab the part never gets old. Oh, pretty sound. That's impressive. Oh, look at that. Triple turret.
Yes, multiple.
Wow. Ooh,
18 millimeters diameter.
silent. No coolant. It's incredible. Carbide drill or just high-speed steel?
Yes, carbide.
Okay.
Yes, yes.
More grooving.
Fly cutting.
Fly cutting.
Yes,
Oh,
yes.
turning.
Yes,
Okay.
It's milling process.
Yes.
Yes.
Broaching.
Broaching, yes.
Speroni. What I want to show in the Speroni booth is what we talked about in the video we just did on a presetter, which is this idea of not measuring and then typing by hand. Used to be that you could print a label, but now there's the ability to actually just take a gun and scan it, and it can push the tool number and the gauge length and the diameter directly into your machine control.
So the same function, but
Okay.
here instead of printing a label, we
Yeah.
are going to select already the
Right.
destination machine. Okay. So at this point, since the tool number is not available, I'm going to enter it now.
Yes.
For example, position 10. And now,
Is it over there?
yes. Position 10.
That's amazing.
Okay, of course, it's the same tool as the
Sure.
one we just sent, but position 10.
So, and any Heidenhain machine would be capable of this?
Yeah, okay. This interface, since it's using specific libraries of Heidenhain, it's available from TNC 530
with
yeah.
option 18. New machine are already capable of this. There is an option which is option 18, but it's like a license that any customer can enable in their machine. But the same integration is available also for Siemens, Fanuc, Mitsubishi, Haas, Okuma. We are already working with other suppliers, with our manufacturers.
Cool. Thank you.
You're welcome.
So this is the relatively new Haas Robot package. So what's interesting about this is you just roll the robot up to your machine, kind of bolts or clips in. I do think you need a service tech visit to do the initial install, but then you're sort of good to go. And what's great is there's no Fanuc pendant. When we had our Fanuc robot with a robo drill, the Fanuc pendant was very difficult to use, and this kind of gives you a turnkey, easy to use solution. UMC 500, we've seen plenty of these, but this has the, I think, 16 pallet pool. Look at this, grinding a variable pitch auger, screw, whatever you want to call it. Really cool, beautiful. Check this out, a little clamshell holder for probing your turret. That's tight. Oh, it's crazy. Oh, and you can turn with the head. Yep. Look at that. Pinch turn. That's amazing.
It will just come down and pick up the prep part with the gripper.
Yeah, unload it, move it over. It's a rotary on a larger rotor, yeah?
Yes, it's a working piece changing system.
Okay. In one spindle or two spindle?
It's a two spindle machine.
Yeah. You can see here now the dual vise, dual spindles, and it's not just 4+1. It actually can do true simultaneous fifth axis. Explain that. It does full 5 via rotation on the effectively C.
So we've got our fixture table, which would be our V axis, and then our table axis, which is our A or U, and then we have our 3-axis stack on the front side. So.
Okay. And you were saying, I mean, it's a trade show demo. You're making a keychain, but it's sort of like a titanium bone plate. Oh, here we go. Tool change, maybe. There we go. Oh, look at that.
You get a
Beautiful.
little bit of idea of
Sure.
the component. I think the smallest tool we go down to is 0.8 millimeters to get those fine surfaces.
Yeah. So on a dual spindle machine, when you have minor variations in gauge length, how does the machine compensate for that?
So a lot of our machines have independent x-axes, so
Okay.
you can control your spindles independently. Some of our larger machines have totally independent X, Y, Z,
Okay.
so which makes it that much easier.
Got it.
That being said, anytime you're using a multi-spindle 2 or 4 spindle machine, you have to take care of the tool setting for sure.
Okay.
So, you know, we work in very close conjunction with the tool presetting guys.
Sure.
I'd say we've had many success stories working with Haimer, and you know they're plus or minus 5 microns on setting up
Yeah.
the tools, if not better, depending on the application, which really allows the machine to do what it can do and the geometric capability and performance that it has.
Yeah. And it looks like it is hitting a bloom laser up there to do a tool check, a brake
so
check.
We can do a tool brake check, and we also have inductive sensors on it as well. We have also run-out checks on the tools. A lot of different features to determine how the tools are performing over
Yeah.
time.
In a true production environment, clearly, yeah.
So this is our smallest machine,
Okay.
which just has 200 millimeters between centers, and our largest dual spindle machines go up to 800 millimeters behind.
Do you have a larger one here?
The 6.
Can we go see it?
Absolutely. So this is a W06, so it's also a linear motor machine.
Holy cow.
So these are some stator housings, just showing some cast components.
Look at this.
One of the nice things here in the production environment, you can imagine I just got done machining that component, I tipped my table upside down.
Oh, look at that automatic clamping.
I've got, it's got to be automatic in production environment.
Sure.
But tip that part down, flush it all off.
Oh, look at
before we
that.
go through the load unload sequence. Another interesting aspect of our machine is having the tool changer directly above the machining area. So in this case, we don't have any arms
Oh, look at that.
swinging into
Yeah, sure.
pick up the part. Doesn't get bent, doesn't get banged up. A really nice, clean environment in regards to the tool magazine.
That was a good pucker factor linking move there. Look at that.
So the really nice thing about that big trunnion doing the workpiece rotation from table A to table U is really your load unload time.
So does this machine have an independent XY in the head?
Yes, this is independent XYZ.
It's incredible. And that's a minor amount just simply for tool wear style adjustments? Or
Any offsets that you're going to make, maybe you got a finicky fixture or whatever, and you have the possibility to offset something a little bit just based on geometric reasons. And that's one thing we always have to tell our customers who are new to dual or 4 spindle solutions. It's just one NC program. You happen to be setting up for 2 parts,
Sure.
2 spindles, 2 fixtures, but the NC program is just one.
look at that. What's the tool changer size?
So we can go up to 320 millimeters in diameter.
And how many tools in it?
This one I think is probably 2 times 40. We can go up to 2 times 96 to really extend it. We go directly vertical. Our tool change magazine just goes vertical so we don't eat up any floor space.
Got it.
And it is all HSK. We don't do any cat work. This guy's probably HSK 63, but we have an option for going up to HSK 100.
Beautiful. this was one of the more interesting machines that I saw at EMO. It was the Micro 5 from C.O.R.E. Super compact, high RPM, 5-axis machine, which in and of itself is cool. What makes this really amazing is, in addition to having built-in tool changer, which is great for a machine this size, it has built-in automation. I think it had 3 or 4 pallets so it could actually load material in and out. So this screams watchmaking like you're seeing here, or other intricate, small, detailed parts. And that idea that you could have this machine in an R&D lab, in your bedroom, somewhere you don't always necessarily see big machining centers, make it pretty cool. Look at that. 60,000 RPM, 5-axis, incredible. Was not expecting to necessarily see this kind of stuff here. In the States, I believe they call these things plate processing machines. A bit out of my expertise, but the ones I've heard about can be a mix of like a cutting style, laser, jet, plasma, oxyacetylene rather, and proper cutting tools. So machining, tapping, drilling, and you can certainly see, I think that's what this is though. Head on the left, I'm guessing is just gonna figure out with the lines what that is, and then on the right you've got a proper Cat 40 spindle. Looks like they've got a pretty good sized tap in there, and you can see over there on the tool change rack some drills, chamfers, insert drills. Pretty cool if you're doing this kind of work. We just had the coolest demo from KERN Engineering. They're actually here at the Bloom booth. So they make software called T-Max. We'd heard about this when we were buying the Okuma. We didn't get it, but I want to be able to get it. So what it can do is really 2 things. One is super intelligent tool life monitoring. So when we drill holes in our fixture plates, we can run this software. It has hardware sensors. It can learn the cuts, and it can better understand where and when your tools are starting to fail, and giving you true graphical data over, again, thousands of holes, days of operations. You can compare tool paths, drills, like really starting to track that data way better than just a built-in tool life monitoring software. The other thing is we had this idea of dealing with variations in material size and not having to change the cam. So basically we want to take an extra 1 or 2 passes around the parts that might be air cutting. Their software has an adaptive function where basically if it sees 0 load, you can choose to have it go to a different feed rate, and it will continue at that high feed rate until it hits the material, in which case it'll go back to your program feed rate. My thought was, how sensitive and reactive is that? One of the things they showed that I think answers that was when their software showed a face mill that started cutting into a part that was misloaded, and the face mill was taking way too deep of a cut. It stopped the face mill at 3,000 RPMs without the next insert appearing to hit the material, which is pretty cool. Literally just about to leave EMO and call it a trip, and then look at this beautiful Micron. Look at that toolpath. As always, folks, hope you learned something, hope you enjoyed. It's great to be back on the road again, even if you have to wear the masks. Otherwise, take care. See you soon.